So let's talk about a sample mean. So up to now, whenever we've sampled something, we have spoken about finding a single object. For example, we'll say, what's the probability that one package of hot chocolate contains more than 5 milligrams, say, of caffeine? That's what we've been talking about so far. But what if we were to have, say, 3 packets of hot chocolate? So we would say, what's the probability that, say, 3 packets of hot chocolate have an average caffeine content of greater than 5 milligrams? That's what we're talking about sample means. So sample means are used the same way as proportions. We use them as an unbiased estimator. There's less variation, and of course, like always, we cannot sample more than 10% of the population. X bar is a sample mean, so this is X bar. That's beautiful. And then mu of X bar is equal to mu. And you'll see this plays out as we go along. And then sigma of X bar is equal to sigma over the square root of n. Okay. So I'll give you a second to copy all this down, and then we'll go on. So a little note here. Whenever we're talking about the sample mean, if their SRS is from an n, that's a normal distribution, then the sampling distribution is also normal. And the distribution is now mu divided by the square root of n. So we can see that the standard deviation, which is our variation here, has been radically changed. It's now divided by the square root of n. Okay, so just write this down, and we'll talk about this more later on, but just something important to understand, that if the distribution is normal, and we take a sample from it, then the sample of a normal distribution is also normal. Kind of makes sense. But let's go and talk a little bit more about this. So when do we use sigma divided by the square root of n? And let's read this. You can read this. You can read the context. And I'll give you a second to do that. So it says on the GRE, the scores look something like this. It's normal. It has a mean of 500. Hey now. And has a standard deviation of 100. A little bit of technical difficulties here. It has a standard deviation of 100. So we're going to fix this a little bit. Okay, that's beautiful. What is the probability that a randomly chosen person scores above 625? Okay. So what is the probability that a randomly chosen person scores above 625? So the probability x is greater than 625. And I want you to see something. When we set this problem up, do we use sigma over the square root of n or just sigma? Let's take a look at this. If I use sigma, which is divided by the square root of n, what's n here? What's my sample size? It says a person. So here my sigma is just sigma. Okay. So the second says, what happens when you have a group of 4 people? So here at P, x is greater than 625. And now I have 4 people. So I have my standard deviation divided by my sample size, which is 4. So when do I use divided by square root of n? Anytime my sample size is larger than 1. Anytime my sample size is larger than 1. And I'll tell you what. I'll pause this video. Actually, I'll stop this video. and then I will work these problems for you on a separate video. That way, if you need just a lecture portion, you can have that, or if you want to see me work a problem, I'll do that in the next video.